Okay, in this video we're going to have a look at how the Earth's atmosphere has formed over time. And if we go back 4 billion years, then what we've got here is a situation where the Earth's atmosphere is very different. There's lots of volcanic activity, and the volcanoes were releasing, we've got methane, ammonia, water vapour and carbon dioxide. So this would have been a very, very hot atmosphere, because these methane, water vapour and carbon dioxide are all gases that absorb heat energy and therefore cause global warming. The Earth's crust wouldn't have been formed, so it would have been in a very molten area, so that would have increased the heat. And what you notice in here, there is no oxygen, and no oxygen means there is no life. Gradually over time, the Earth's crust started to solidify, and that helped the Earth to actually cool. And as the Earth starts to cool, then the water vapour that's been released from the volcanoes starts to cool and to condense. And as this starts to condense, we'll put that word on here, as this starts to condense, then we start to get the oceans forming. And once we get the oceans forming, what then happens is that carbon dioxide has been released, will actually then start to dissolve into the oceans. So carbon dioxide drops into the oceans, and that removes a huge amount of carbon dioxide from the atmosphere. Once that carbon dioxide is in the ocean, then we start to get very simple, single cell, in some cases, creatures that will start to use that carbon dioxide. For example, we know that the shells on creatures contains that carbon dioxide that's been transformed by the organism, and that means that it starts to trap that carbon dioxide inside here. So they start to use up the carbon dioxide. Alongside that, we then start to get very, very simple, I've drawn it as a tree here, but it wouldn't be a tree, very simple single cell organisms that are able to do photosynthesis. Now if you remember, photosynthesis takes in carbon dioxide and gives out oxygen. So this process now starts to produce oxygen, and that's where we have that massive change in the Earth's atmosphere, because now we're starting to get oxygen forming. If we were to do this as a little graph to show you as a timeline, where you can see here, if I just move this around a little bit, here's my little graph. So we've got time up to present day, going back through time, and it's just a percentage of these two gases. So the CO2 starts off very high, the carbon dioxide, and then drops rapidly to quite low levels. The oxygen is none at all, and then starts to increase to higher levels. Here to remind you, the carbon dioxide, where does it go? Well, the first thing, it dissolves in the oceans, so this is representing the oceans, and then here we start to get more carbon dioxide dropping because the plants start to use it for photosynthesis, and that causes the increase in oxygen at that point in time. And that leads us to present day, and in present day we get ourselves into this situation now where we know the atmosphere contains 78% nitrogen. The oxygen has increased to a point where we've got 21% of the atmosphere is oxygen, and then we've got the remaining 1% as other gases, which includes carbon dioxide, water vapour and the noble gases.